Okay guys, today we're going to look at energy in circuits, and there are 5 equations that you should learn and be able to use. Now, to be honest, we're going to cheat a little bit here, because whilst there were 5 equations, there were 3 relatively straightforward ones, there were 2 slightly more difficult ones. So we're going to focus on 3 and play the odds game a little bit, because on a foundation paper the odds of you using 2 of them are fairly low, but we'll do them anyway just in case. So first things first, what is charge? Well, charge is the flow of electrons around a circuit. If you think about electrons, they are charged particles orbiting around the outside of atoms. When they move around a circuit, what you have is a movement of charge. So charge is measured in coulombs. That's the number of electrons that are moving around a circuit. The flow of that charge is then the current. Okay, so charge is measured in coulombs, big capital C for coulombs, and it's given the symbol Q. Q for coulombs, no idea why. An amp is a coulomb per second. So if you've got 2 amps in a circuit, that means 2 coulombs of electrons are moving past the point every second. So the equation for this is current is charge per second, coulombs divided by time. We rearrange that into this. Charge is current times time. Q equals I times T. So equation 1 you want to learn today is that. Quit. Remember, quit. Q equals I T. Q for charge, I for current, T for time. Okay, that's equation number 1 to learn. Right, what about voltage? Well, voltage, this is known as the potential difference. It's the push that flows electrons around a circuit. Now, as a physics point, you can say that there's also a measure of the energy provided to the charge carriers. It's defined as the amount of work done per unit charge. So it has an equation, which is potential difference is energy divided by charge. The odds of you meeting this on a foundation paper are very, very low. So we can learn that equation as E equals Q times V. Personally, I don't think it's going to come up. I've yet to see a question on this on a foundation paper. Doesn't mean it won't, but the odds are against it. Right, power. This one does come up a lot. Power is the rate of energy consumption or transfer. It's a speed measurement. How quickly is that energy being transferred? And it's a product of both the voltage and the current. The more electrons moving per second, the higher the current, the more power goes through. The bigger the push, the more power. So the equation for this is this. P equals I times V. Power is current times potential difference, or voltage. Power is current times voltage. The way to remember that is that. Pigs in velvet. So there's another mnemonic. Mnemonics are brilliant devices to help you remember equations, because that will help. We've already had quit, now we've got pigs in velvet. Okay. We can rearrange this equation and have a look at this. So this is power is voltage times current, or power is current times voltage, pigs in velvet. So let's have a look at an equation. So power is current times voltage, I times V, which is 0.4 times 230. That's going to give us 101.2 watts. Watt is the unit of power. Okay, not a question, that's the answer. So what is the voltage across a microchip? It has a normal operating power of 0.5 watts and draws a current of 0.1 amps. Now I've got to rearrange it. So voltage on this side times current there. So if I take current over, change the size, change the sign, voltage is going to be power divided by the current. So that's going to be 0.5 divided by 0.1, which gives us 5 volts. Right, so that's how we use that. We're going to be practicing this equation shortly. We can also calculate power using resistance. Now, I can do this by adding combining 2 different equations. I wouldn't bother memorising this, and the odds of it being on a foundation paper are low. But I'm going to show you anyway. But if you want to just go la 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 for the next 30 seconds, that's not the end of the world. So let's look at these 2 equations. We've already got V equals I times R, vampires in red, we've memorised that. And then we've got P equals I times V. Well, I've got P equals I times V, V equals I times R. So what I can do is I can put this in place of that. That's going to give me P equals I times R, which you can simplify. I times I is I squared. So P equals I squared times R. So that's the fourth equation you should learn. If I'm honest, are you going to? Probably not. Is it going to come up in an exam? Probably not. But just bear in mind that's where it comes from. If I need to use it, I combine those two equations I have learned. Pigs in velvet and vampires in red are stuck there, so I can make it if I have to. So those are the 5 equations you need to learn, right, in theory. That's what the exam board says. What questions are going to come up? You're going to get questions on vampires in red. You're going to get questions on quit. You're going to get questions on pigs in velvet. The other 2, I would be surprised if they appear on a foundation paper. I've yet to see them do so. So just bear that in mind. So let's look at those 3 equations in terms of a couple of questions, and then you can have a go at doing some of these. I've got a couple of worksheets with questions on these for you to have a go at. So let's kick off then. Domestic voltage is 230 volts. For the 40 watt, 60 watt and 100 watt bulbs, calculate the current. Right, what have I got? I've got V, I've got P, and I've got I. I've got current, power, and I've got voltage. So I'm doing pigs in velvet. So I want to calculate the current. I've got pigs in velvet, but I need to rearrange it for current. So I want to get I on its own, it's times by V there, so I'm going to swap it, change the sign to change the sign. That's going to give me current is power divided by voltage. So for each of those, the power, I've got 40 watts divided by 230, 60 watts divided by 230, 100 watts divided by 230, and that gives me those 3 current values there. So that's how you use the equation. Okay, remember the right equation, look what's in the question, identify the equation you need to use. That's half the battle then just plug some numbers in and press equals. So let's look at some other examples here. First one, what potential difference, i.e. voltage, is needed for a 1 amp current to flow through a 12 ohm resistor, and then a 30 milliamp, so that's 30 thousandth of an amp, to flow through a 26 ohm resistor. So what equation do I need? Well, that one there, I've got V, I've got I, I've got R, and it. That's vampires in red. Second one, power rating. I've got a voltage and I've got a current. So for question 2, it's pigs in velvet. Question 3, and asks me for current. It tells me that it's a 230 volt mains power supply, and it gives me the power. So I'm after current, but I've got voltage and I've got power, so I'm in pigs in velvet again. But this time I've got to rearrange it. I want I on its own, so it's going to be P over V. Last but not least, how much energy is transferred in those? Actually should read, what is the charge? What is the charge transferred in each of those? So for that one, I need quit. Q equals I times T. Slight complicating factor there is that's 2 minutes. I need to put that into seconds. So what I'd like you to do is pause the video and have a go at those questions, please. And then we'll have a look through them in a minute. Right, okay, I'm hoping you paused it and you've had a go. If you haven't, we're going to crack on anyway, and let's look at some of the answers. So first things first then, what potential difference is used to make a current go through that? So I'm virgins in red territory, so that's going to be V equals I times R. 1 amp times 12 is 12 volts. For the second one, 30 milliamps, I convert that to 0.03 amps, so 30 milliamps divided by 1000 basically, and then I'm going to plug that in, so that's going to be vampires in red. V equals I times R, so that's 0.03 amps times 26 ohms is 0.78 volts. What about the power rating for a bulb then? So this is pigs in velvet. The current is 0.25 times 230. That's going to give me 57.5 watts. For the second question, that's going to be 0.5 amps times 120. Pigs in velvet, it gives me 60 watts. For question 3, I've rearranged it. So pigs in velvet, so they get current on its own, I is going to be P over V. And so I is going to be P, power is 2000 watts, divide that by 230 volts, gives me 6.7 amps. Question B, 1.2 kilowatts, 1.2 thousand, so that's 1200 watts. Divide by 230 is 5.21 amps. And 400 watts, so that's going to be 400 divided by 230 is 1.74 amps. Right, the last bit of this, how much charge is transferred to each of the above when connected for 10 seconds? Now I've only done A, I haven't done the microwave and the computer, but you get the gist of it. 10 seconds, Q equals I times T. So the charge, Q, is going to be the current, which is 6.7 amps, times by the time, which is 10 seconds, which is 67 coulombs. For 4B, again I'm going to use the 6.7 amps because I'm still working out for the kettle. This is over 2 minutes. Now 2 times 60 seconds is 120 seconds, so 6.7 times 120 seconds is 804 coulombs. So that's how you do the calculations. It's over to you to have a go at it really now. But just to remind you, these are the 5 equations you should learn, of which 3 are going to be the ones that you're probably very, very likely going to get questions in. So V equals I times R, vampires in red. Q equals I times T, quit. V equals I times R, sorry, P equals I times V, pigs in velvet. Learn those 3 mnemonics or create your own. I don't mind at all as long as you memorise those equations and you're able to use them. Guys, when you put your thinking caps on, your math skills are awesome. So you can do these questions. But please have a go at them. I'll ping you out the answers later. But in the meantime, take care of yourselves and I'll speak to you soon.